Physical properties of the electric current. 1. Current intensity. 2. Potential difference. 3. Electric resistance. Current intensity. The intensity of light isn't determined by the number of electrons, but by the rate of the flow of electrons through a specific point in the wire. The electric current intensity. It is the quantity of electric charges passing through cross-section of the conductor in 1 second. Current intensity equals quantity of charges over time. I equals Q over T. It is measured by using a device called a meter that has a symbol A. A meter is connected in series. Activity 1. To show the connection of a meter in the electric circuit. The measuring unit of the current intensity as ampere. The measuring unit of the quantity of electricity is coulomb. The measuring unit of the time is second. Ampere, the electric current intensity passing through a circuit when a charge of 1 coulomb passes through a given cross-section in 1 second. Coulomb, the charge transferred by constant current of 1 ampere in 1 second. Two, the electric potential difference. The temperature moves from a hot object to a cold one, and it continues to move until the two temperatures are equal. The movement of temperature does not depend on the size of the two objects, but on the difference in their temperatures. The temperature difference between two conductors determines the transfer of the heat energy to and from an object. If two charged conductors touch, the electric current will move from the high conductor to the low one until they become equal. The flow of charges does not depend on their amount, but on the conductor potential difference in comparison to the other conductor. The difference of electric potential between two conductors determines the transfer of the electric charges to and from an object. Potential difference equal work joule over charged coulombs. V equals W over Q. A joule is the amount of work done by a force of 1 Newton moving an object through a distance of 1 meter. Volt is the potential difference between two poles of a conductor on doing a work of 1 joule to transfer a quantity of electricity, 1 coulomb. The electric potential of a conductor. It is the condition of an electric conductor that shows the transfer of the electricity to and from it when it connected to another conductor. The electric potential difference of a conductor. It is the value of the work done to transfer a quantity of electric charge between the two ends of this conductor. The potential difference is measured by using voltmeter that has a symbol V. Voltmeter is connected in parallel connection to measure the electric potential difference. The measuring unit of the potential difference is volt. The measuring unit of the work is joule. The measuring unit of the quantity of electricity is coulomb. The measuring unit of force is Newton. Electromotive force, EMF. EMF is the potential difference between the two poles of the battery when the electric circuit is open. No current passes. EMF is measured in volt. The voltmeter V to measure the potential difference and EMF. It connects in parallel between the two terminals of the conductor to measure the potential difference. It connects in parallel between the two poles of battery to measure the electromotive force when the circuit is open. 3. The electric resistance. It is the opposition that the electric current faces during its movement in a conductor. It is measured by using an instrument called an ohm meter. The measuring unit of the electric resistance is ohm. The ohm is the resistance of the conductor that has an electric current of 1 ampere and when the potential difference between its poles is 1 volt.